welcome back to SAT Math Question of the Day. Here we have our question of the day. Please read it, pause the video, come back to it, and we will hopefully show you different ways, or at least one way to approach it. The greatest snipe, wow, I never even heard of the word snipe as a bird. The greatest snipe is the fastest known bird, basically.
Migratory.
Migratory, but that I don't think that's going to matter. But, and that's unlike yesterday, read the whole question before writing anything down. Scientists found that the bird can fly nonstop for approximately, 4,200 miles. Whoa! If the bird's speed is an average of 98 kilometers per hour. Wow, that's fast. How many hours can the great snipe fly without stopping? And it goes to go for 4,200 miles. So, this is a unit conversion problem. If you didn't know, it says on top, unit conversion problem. So, there are different ways to do it. Unit conversion problems are all basically ratio problems, but we are such a big fan of using unit analysis, because unit analysis is so clean. So, better we do that, and then maybe we could do other ways. You want the final answer to be in hours, right? That's the final answer. How many hours can the bird fly without stopping? So, it flies at 98 kilometers per hour.
So you want the kilometer per hour to be in the denominator.
That's right. 98. So you want 1 hour to be down here, 98 kilometers. And then all we need is a conversion between kilometers and miles, and it's going 4,200 miles. Wait, something's wrong. It's going.
Yeah,
the hours per mile.
And then the miles is in the numerator.
Miles is in the numerator.
And then you multiply that by miles per kilometer.
Miles is in the numerator. 4,200 miles.
Yeah.
And then you put miles down here.
Yeah.
Right. Miles down here. Kilometers up here.
Yeah.
And it's 1 kilometer is 0.62 miles.
Yeah.
And that's how you do it, right? So the units do all the thinking for you. And then that's why, I was doing it, I stopped and I had to get the units right, which models realistically how you do the problem. You just got to do it so that it works.
Yeah.
So that's it, right? The miles cancel. I'll use a lighter thing. The miles cancel, the kilometers cancel, and we're left with just hours. So that's the answer. The answer is 4,200 divided by 98 divided by, and then that is 0.62, and that is the answer. Again, just like yesterday, we leave the answer. We do it at the end. We don't do any intermediary steps. And then we check. And so the problem like this, again, the units do all the thinking. This is also a speed time distance problem, isn't it? Velocity, speed is distance over time.
Yeah.
And you could also do it that way, right?
Yeah. Then you get from that, time is equal to distance divided by speed.
Right.
You know the distance.
Time, let's do it that way.
And you know
time is equal to distance over speed.
Yeah.
So let's do it that way. So we know the distance, 4,200 miles divided by the speed, which is 98 kilometers per hour. Right?
Right.
So that is the time.
Right. But the numerator is in kilometers, numerator is in miles, denominator is in kilometers. So I have to convert either kilometers to miles in the denominator,
right,
or the miles to kilometers in the numerator.
So, but they say 1 kilometer, so you could do this little trick. 1 kilometer is 0.62 miles.
Yeah.
So that means if 98 kilometers is 98 times 0.62 miles.
Yeah.
So this is the answer.
Oh yeah. So it goes about 60 miles an hour, like a car drive on the typical legal speed on highways in the United States. Right. It's about 60 miles per hour, which translates to 100 kilometers per hour.
Right. So notice that these answers are exactly the same. This is not a bad way to do it. This is not a bad way to do it. Speed is distance over time.
Yeah. And then you just so how many hours does he fly? Was she?
Well, if it's 100 miles an hour, it would be about 42 hours, right?
Oh, wow.
So the answer has to be it's going to be roughly about 42 hours, but then we have to use the calculator. So, calculator is 4,200 divided by 98, and then divided by 0.62. 69.
Well, it's more than 42 hours.
So what's wrong? Oh, not speak. No. I'm wrong. I'm assuming 100 miles an hour. No, it's 60 miles an hour. 60 miles an hour. It's 4,200 divided by 60 is 70 miles. This is about 60 miles an hour. So you don't divide by 100, you divide by 60. 4,200 divided by 60, you get 70 hours.
Yeah.
But if you do this problem, you get this. But now you have to pay attention to what they want the answer in. Tenths. Go back to yesterday's video. I made that mistake. 98 divided by 0.62. So the answer on a calculator is, final answer, bold, 69.124. Now you have to round that to the nearest tenth. So that's 69.1, right?
Yeah.
You come to think of it, using unit analysis is maybe a little overkill on this. It may be better to do this.
Yes.
Yeah.
Yes.
Because it's sort of, if you do the unit analysis, it's actually a little complicated. Unit analysis is better when you're going ratio to ratio, as opposed to going problem to problem. See, here the final answer here is in hours. Unit analysis is best if you want to go from, let's say, kilometers per liter to miles per ounce or something.
Well, I like unit analysis when the problem is tricky or confusing.
Agreed.
And that when I see when it appears to be obvious, I skip unit analysis.
Yeah, you're right. It would have been better just to do speed is equal to distance over time, which is really, really a very, very basic formula that everyone taking the SAT should be familiar with.
So it's a matter of the understanding, the connection between the three quantities, time, distance, and speed.
Yeah.
Combine that together with the need to convert between a kilometer distance units and mile distance units.
Right. Exactly.
So what you could do is take one of the numbers and convert it to the other units, and there are two numbers. So you might two approaches. Number one, convert 4,200 miles into kilometers.
Yep.
By dividing by 6,200, and then do the quotient of distance to speed in terms of kilometers.
Yeah.
Second approach is you do the calculations in terms of miles. So you start with distance of 4,200 miles. Speed is 98 kilometers per mile. Convert kilometers into miles
Yeah.
of speed. They multiply 98 by 6,200 to convert that to miles per hour.
Right.
And then you divide distance in miles by speed in miles per hour.
Right. Exactly. So, and because they give you explicitly 1 kilometer equals 0.62 miles, you just do it here. You just cross out the word kilometer. 1 kilometer, there's a 1 implied here. 1 kilometer equals 0.62 miles. You just do that, and then you just have, so that's easy. That's
So the speed in kilometers per hour equals 0.066200 times 98
right.
miles
That's right.
per hour.
Yep.
Okay.
And
Nailed that. Yeah, so let's see if they agree with us.
And then, by the way, you could do a little bit of unit analysis here. You've got miles divided by miles per hour, and if you use the complex fraction relationship, we got miles divided by miles per hour is miles over 1 times hours divided by miles. Miles cancel, and your answer is in hours, which it should be 69.1. So let's see.
It's a manifestation of the rule,
right?
A over the fraction B over C is equal to A times C divided by B.
Right. Yep. Okay, unit analysis keeps everyone honest when you're doing these types of problems. Okay, so, let's clear this thing. And it was 69.1, wasn't it? Yeah.
Yeah.
Okay, so let's see. 69. We actually have to write it in. I have to type it in. 69.1. Let's see. Okay, it's exactly 69.1. Let's see how they did it. Get another hint, a 3-step problem.
Yeah.
They're using unit analysis also.
Yeah.
First, let's convert the bird speed to miles per hour. To determine how long it'll take, we divide by the speed. I wish they would give the formula. Wait, what are they doing? They're doing time. Oh, that's confusing. Why don't they show the formula? Speed is distance over time.
Well, they say it in English.
Where?
Here. To determine how long it will take, we divide by the speed.
Yeah, but they don't give the formula.
They don't. They give it in English.
Distance.
If you understand it in English, you don't need the formula.
I don't know. It would have been better if they gave the formula. Because distance is speed times time. What speed? We divide by the speed. We divide the distance by the speed, right? You see, this is the other way to write it, right? Distance.
Yeah, but when you think about it, the speed is how many miles you go in 1 hour.
Right, of course.
Right. And if you have a certain number of miles, you divide the trip of miles into the intervals of how much you drive in 1 hour. And how many of those hour periods is the time in hours it takes to take the trip in miles. You have your trip in miles. You know the speed. The speed means how many miles in an hour.
Right.
You want to find how many hours is the trip. So you think your trip is like a few hundred miles, and you see how many of those hourly intervals during which you'll travel like 60 miles fits into the 300-mile trip. So it's a division problem.
Right. I don't know. I think it's nicer to have a formula, which we all know, and then solve for what you need. You want to know time. So you
I
solve
think
this
it's nicer. I think
equation
it's
for
nicer
time.
to practice and learn to think.
I don't know. You have to, but you have division here. It's so easy to divide It's so easy for division to do it the wrong way. It's so easy to do that. But if you use the units to help you, then you don't make that mistake. See, they did, right? They were careful. They did
Yeah.
put the units in. They didn't do what probably many people do, which is just write the numbers down without the units. That is
Well,
really dangerous.
in science and engineering, unit analysis is most helpful
Yeah.
when the scientist doesn't have the intuition about what the quantities mean.
Right. Right.
And so when it's tricky, when it's out of one's experience, then
Yeah.
the units are really helpful to make sure that you don't make a mistake.
But I mean, if your intuition, let's say if you plan to drive 300 miles and you are traveling at 60 miles an hour, how long will it take you? You don't have to sit there and do the calculation. 300 miles, I'm going 60 miles an hour. Of course, I'm going to be going 5 miles.
Yeah.
5 hours. 5 hours. Of course, I'm going to be going 5 hours.
Yeah.
So if you're doing that in the car and you're talking to your family or your friends, oh, we have to drive 300 miles, 60 miles an hour. How long does it take us? It's going to take us 5 hours. That's fine. That's totally intuitive. But here you have weird numbers. And you may not realize that it's the same idea. You have to divide the 4,200 by the speed. They also are, we love to be critical here, but they're also wasting the time with intermediary calculations. Is that the word? Intermediary calculations, which are not a great idea. You want to write the answer in one thing and then do the calculations at the end so that you can catch any mistakes you make. So.
Oh, yeah. They actually doing the.
Yeah, they're doing.
Yeah, the multiplying them out. That's right. Yeah.
But at least they did unit analysis. At least.
Well, you could again. What they should do is they say start. This is one, and don't bother with this, and or write it as instead of writing this, you write 98 times 62 hundredths.
Right.
Sorry.
That's right.
62 hundredths
divided by
miles per hour.
Right. Because very often, well, on the non-calculator, there aren't in the digital SAT, everything is a calculator. Another advantage to writing this here is because it is certainly possible to have a problem where you can have a 4,200 here and then a 98, right? And then a 0.42. And then if you do that, then you could see that, you could do this thing really, 4,200 divided by 0.42. You don't need a calculator for that. But if you get an intermediate step, you're sort of wasting your time. So, or this could have been a 98, right? This could have been a 98. It could have been 9800 divided by 98 divided by 0.42, right? And then without a calculator, it's 100 divided by 0.42. That's an advantage. Really, trying to stay away from intermediary calculation. Okay, so that's it, right? So today we do Throwback Thursday, where we go back to a test from 20 years ago, and we look at a question, and you can see that they asked slightly different questions. Well, sometimes dramatically different questions. Not all the questions were dramatically different, but the questions are had a different feel to them. So here's a question. Hopefully, it will come up. From a practice book, from the SAT practice book, official practice book from 20 years ago. and this question seems to have a whole different feel to it from some of the modern questions. Questions 8 and 9. So we'll do 2 questions. For any positive integer k, let that boxy thing k represent the greatest odd integer that k divides. And they're very nice. They give you an example. The box of 36 is 9. So now they want to know what the box of 30 is. What is Seth writing? Prod of k's. Product of k is odd. What? Prime? Prime factor.
So 30 equals 3 times 2 times 5. What's it? And then so the product of these two, 3 times 5 is 15.
Or, you can just look at the answers. They want the greatest odd integer. So the odd this can't be. These can't be the answers. So you can just really do multiple choice, right? 5 is not. 15 is odd, and it is greater than 5. So 15 has to be the answer. And here, all of these are even.
But it's faster to use the principle of prime factorization.
Yeah.
Every number has a unique prime factorization.
Right.
And then the largest odd divisor is the product of all of the odd primes.
Oh, I never thought about that. In other words, the only way if you multiply any two if you do any two odds, you will always get an odd. Is that true?
Oh yeah.
Wow, I never even thought about that. I guess that's
well,
true.
I thought of it. The proof is if every odd number has the form 2n plus 1.
Okay.
So if you multiply 2 odd numbers,
right,
you get 4 times some number plus 2 times some number plus 2 times another number plus a 1. Right? And all this stuff, this is even.
That's a cool proof. Wow,
yeah. That's why. It's because you didn't take many math courses like me.
No, so let's and all right. So the answer here is 1. All these are odd. All these are even. So let's just mention who we are. Seth's a PhD in math. You can probably tell by his really cool proof from MIT. He's been teaching at SUNY Albany for many years, but he's retired now. He's Professor Emeritus of Computer Science there at SUNY Albany, New York. And I'm Joel. I have a PhD in mechanical engineering, so I take the more practical approach. And I never really thought about this before. So we're here to hopefully offer approaches on how to do SAT math questions. We hopefully show you with more than one approach per problem, so you can see different ways of thinking, different ways to peel the onion, or different lenses into a problem. And the approach for studying the SAT is not a bad. We suggest going to Khan Academy. They offer 2 classes and 2 courses, the digital and the non-digital. Talk to your guidance counselor to see which test you're slated to take, and to go ahead and Khan and practice on Khan accordingly. And of course, take as many actual SAT sanctioned tests you can, given by the College Board, that are released by the College Board. So that's our introduction, which we do last because we want to get to the problems. And that's okay. So you agree, this is an unusual problem. Even in Khan practice, you never see problems like this anymore. So this is a particularly fast problem. I would consider it under the auspices of number theory. So yeah, so that's it. Okay, any other thoughts of anything? No? Okay. So please give us comments. We love comments because we use the feedback. We take the feedback very seriously. And please dislike us. And if you have any SAT math questions, email them to us at satmathquestionoftheday@gmail.com, and we'd be more than happy to do them online here. Okay, everyone. So I guess have a great day.
Bye bye.
Bye bye.